Okay, so here's what I'd like for you to do. I want you to take out a scrap piece of paper or a sheet of notebook paper. Make sure it's something you don't care if it gets ripped up, okay? So everybody's getting out a sheet of old paper. Now we are going to rip it up and you ultimately will throw it away. So don't make it something good. You can just use a plain sheet of notebook paper.
Can I have writing on it?
You can have writing on it. But it has to be something that you're okay with throwing away.
You need to break them on that one. Oh,
All right, here's what we're going to do. Don't look so excited, Paul. It's going to be fun. I want you to take your sheet of paper, and out of each corner, I want you to tear a square. Now, I don't care how big your squares are, and I know they're not going to be perfect because we're tearing, not measuring and cutting. We don't have time to make them perfect. But take the same size square out of each corner, okay? I don't care how big you make your squares, but they should be the same in each corner. Close to the same. It's not going to be exact, I know that. But you should have a piece of paper then that looks something like this. Because you're going to cut the corners out. We're going to go to the recycle and throw all this away in a minute, but let's just get this project done. You're gonna like it. Now, as soon as you have the corners cut out, I want you to start folding up the flaps that you created. You should have 4 flaps. And when you fold those up, you'll have a nice little box. Here's my box. So you're going to fold up your flaps, just like see how I did it? I folded up my flaps. And you're going to have a little box. Okay, so if you have just like that, make a fold. Do that all the way around. And then you'll have, you open up the flaps, they'll stand up and you'll have a little box. Hurry up, you're behind. Now, after you have your box made, just kind of hold it up like this. And look at nicks and curvings here. Look at the, hold them up, boys. They both started with exactly the same size sheet of paper. But what happened? Their boxes are very different, right? Look at you two. Look at Hannah's and Bailey's. Started with the same paper, but the boxes are different. Oh my gosh, look here. Emily and Marley. Totally different boxes. Now, what made them different?
The size of the square.
The size of the squares. Now, here's the deal. Suppose I were a really nice teacher and I'd gone out and bought a bunch of M&Ms. And I walked around and I filled each of your boxes with M&Ms. And then I said, count them. Do you think everybody's box is going to hold exactly the same number of M&Ms? No. Some of them are going to hold more than others. Our job as a calculus student, because this is actually one of the, there are certain problems that are just in every single calculus book. And one of them is the box problem. Maximize the volume of the box. So we want to take your piece of paper and we want to make the volume of the box that you create by cutting out the corners. Those are the corners you cut out. And then you folded up the flaps and you made a box. We want to maximize the volume of the box. And like Emily or somebody back there said, it all depends on the size of the squares that you cut out from the corners. So when I look at problem number D at the top of page 14, it says my paper is 12 by 14. So this paper started out being 12 by 14. So pretend your paper started out that size. Okay? Now, this was my original paper, and it was 12 across. Now, the box is only this far across. So if the original paper was 12, how far across is my box? What?
12 minus X.
Close.
Plus it.
Not 12 minus 1x, but 12 minus 2x. Because didn't we take this 12 right here and cut out this x and this x? So the box width is actually 12 minus 2x. Now what about the length of your box? You cut an x off here and an x off here, so that length would be 14 minus 2x. Now,
These are the problems I always mess up.
get over it. Now, when I do volume, what's my formula for volume from back when I was a sophomore? Length times width times height. And you have told me that your length is 14 minus 2x. Your width is 12 minus 2x. Now, what's the height? Think about that. How tall is that box? Isn't that box this tall?
2X.
Not 2x.
1X.
The height is just x. The height is x. So the volume of my box is 14 minus an x on each end, 14 minus 2x, 12 minus an x on each end, and then x. Now, for some reason, we always forget this little x on the end. Remember, you need length and width and height. So you're going to have three things multiplied. Before we go any farther with this problem, because I promise you, this is going to be a test question. 100% promise you. In fact, it's probably going to be a semester exam question too. Okay? But it's easy. Listen, this paper was 12 by 14. What if I had a piece of paper that was 8 by 10? What would be the volume of the box if I cut these corners out, just like I did before, if it were 8 by 10? What would that volume be?
8 minus
8 minus 2x, 10 minus 2x, times x. The equation is going to be exactly the same every time, except whatever the dimensions of the paper are will change, but everything else is the same. Do you see that? So we're not ever going to have trouble writing our equation. It's always this minus 2x, this minus 2x, and x. Okay, so question number 1. Write an equation for the volume of the box. There it is. You do not need to FOIL it out. I don't want you FOILing it out. Just leave it be. That's your equation. Now, domain. Remember, domain is what happens to my x's, or tell me about the x's. Now, I want you to think about this piece of paper for a minute. X is how much you're ripping off each side. Okay? Now, when I do domain, I usually say, okay, all real numbers. Could x be every number in the whole wide world? Could you take x off either side and have it be any number in the whole wide world? For example, could x be negative 10?
Yeah.
It could.
No,
That square could be negative 10 across.
it can be negative.
It can't be negative, which automatically means it has to be bigger than 0. X is going to be, the lower boundary 0. Now I got to find the upper boundary. Could x be 100? Now remember, this paper is 12 across. I'm taking a chunk off each side. Could I take 100 off each side?
No.
No. Could I take 10 off each side?
Yeah.
Whoa, whoa, whoa. It's 12 across. I'm taking a piece off both sides. Can it be 10? No. How big could it be? All the way up to 6. Your domain is everything between 0 and 6. Now, I want you to think about that for a minute. First of all, we used 12 and not 14. We always use the smallest dimension. Keeping in mind that I have to take a chunk off both sides, if there's only 12 across, doesn't it make sense that the most I could take off is half? You gotta take a piece off both sides, equal pieces. If you only have 12, then the most you could take is 6. Right? Let's come down here to this box. Remember, it was 8 by 10. So the domain for this box, always bigger than 0. You're never going to have a negative number. Now, what's my smallest dimension? Ignore my picture. The smallest dimension is 8. You're taking a chunk off both sides, so Paul, the biggest it could be is 4. Half the smallest dimension. That's your domain every time. X is between 0 and half the smallest dimension. Althea's writing that down so that she remembers it. Since you don't get to see Mrs. Ford tomorrow, she's saying, I might not remember this by what would it be, Friday? So I better write this down. My domain will always be between 0 and half the smallest dimension. Now, I'm going to get out my trusty graphing calculator. And of course, if I don't have one, then I'm in trouble when it comes to this problem. Because while you will learn how to do this problem by hand in your differential calculus class, you probably don't know how to do it by hand right now.
So we have 2 domains.
No, this is a separate problem. This is the domain for the one on the paper. I did another example to show you that it matches exactly. That's a different example. All right, everybody got your calculator out? First thing I want you to do is go to window. When you told me that x had to be between 0 and 6, that is x min and x max. So 0 for x min and 6 for x max. Y min in these problems, this is y, this is the volume, y min will always be 0 because it represents the volume. And volume can't be negative, so 0 would be the lowest it could go. Y max is the iffy one. So let's put 100 in. I'm guessing we're going to see what happens. So everybody has Y max set at 100, right? Don't worry about anything. It's scale. It should be at 1, but don't worry about it. It doesn't matter. All right, so I'm going to say this one more time, and if you're not listening, I'm not repeating it. This is X min and X max, whatever your domain is. Y min is always going to be 0. Y max, you're going to guess a number, because that's really going to be the answer to the question. I don't know how high it goes. So now I'm going to Y equals, and I'm going to type in this equation exactly the way I wrote it on the board. So I'm going to have a parentheses, 14 minus 2x, parentheses, parentheses. I'm going to type it in exactly like I did it on the board, like I wrote it on the board.
Where do you put that?
In Y equals. Go to Y equals and type in this equation. y max, I said put in 100. And then go to y equals, where you type in equations on your calculator. The very first button on the calculator says y equals. And then hit graph. Now, did your picture look something like this? Okay, that's a problem for me, because I am looking for the maximum volume. And the maximum would be some point up here, right? Because this thing's going up like that. So I'm going to go back to my window, and remember when I guessed 100? It wasn't big enough. So I'm going to go back to my window, and I'm going to make y max 200 and press graph. Now, all that's important, groupies, is that you see the top of the hill. With a 200 as my y max, can I see the top of the hill? Okay, now let's make sure we understand this. Could somebody else have put in 300? And would it have been okay? Yes, as long as you can see the top of the hill, whatever number you picked is fine. Now, once I've seen the top of the hill, then I'm going to find my maximum. Do you remember how to do that? Second calc. Everybody press second calc. Calc is in the top row buttons. Press second calc. And then you see the option that says maximum. Right? We did this before, I think, didn't we? And we press enter. And then we have to do that right bound, left bound thing. So I'm moving my cursor to the right, or excuse me, to the left first. Then I'll move it to the right. And then I will put it up at the top where it belongs. And my maximum point, because now I see my hill, my maximum point is 2147, 160, 584. Anybody match that for a maximum? Well, I haven't answered the question yet. This is what my calculator says the maximum point is. So now I have to decide if I'm going to pick this number or if I'm going to pick this number. Now go back to your equation. What did x stand for? When you wrote your equation, what did x stand for? The size of the squares. What did y stand for when you wrote your equation? The volume. Okay, so if I want the maximum volume, I'll pick the what? And the answer to the question is 160.584 cubic inches. That is the maximum volume of the box. So if you had a piece of paper this size and you wanted to build the biggest box you could, you would cut out squares that were that big. Those squares produce this volume. All right? That's a calculus problem. You just did it. All right, let's try the next one on the sheet. It's the same thing. Now our paper is 20 by 24. And we're going to cut out corners. This is how we're going to build our boxes every time. When you get a little more advanced, you'll put lids on them and all kinds of stuff. We're not doing that. We're building a box just like the one you made. Write an equation for the volume of the box. You should be able to do this in a cinch. What is our equation for the volume of the box? 24 minus 2x.
Times 20 minus 2x.
20 minus 2x. Beautiful. Remember, these equations never change. The only thing that changes is these two numbers right here, and that just depends on how big the paper is that you're starting with. Now domain. That means X is going to be between two numbers because there are limits on what X can be. 0 and something, always 0. And what did I tell you the something always is? Half of the smaller dimension. So my smaller dimension is 20. So this is going to be 10. Now when I go to my calculator, that 0 is X min, and this 10 is X max. So let's go ahead. Let's reset our window. Type in your new equation. You got to type in a new equation. You can't use the old one. Now, maybe you did the same thing. I changed my X's because these were my X's. I did not change my Y max. So the same thing happened to me that happened before. It's going off the page. So how do I fix that? Because I have got to see a picture that looks like this, kids. I've got to see the top of the hill.
What's the Y min?
Y min is always 0, and Y max is, you got to pay attention. Y max is the one that we're playing around with till we get it right. I had it at 200. I'm going to try 500. Oh, 500 is not big enough. All right, so you did 700, you say?
That doesn't work.
That doesn't work?
It's like
1,000.
1,000 sounds like a winner. 1,000 worked. So Y min is always going to be 0. You can't have a negative volume. But Y max, you just have to keep playing with until you see this picture. So somebody said 1,000, and 1,000 worked for me. Now, would 900 have worked? Probably. Would 1,200 have worked? Sure. You just need to see the top of the hill. All right, so then what do? Now we see the top of the hill. We need to find that point right there. So second calc, down to maximum, because that's what we're looking for. Left bound, move the cursor over here somewhere. Right bound, move the cursor over here somewhere. And then guess. Move it up to the top. And my maximum is 3.62, 774.16.
Hit 4.
Anybody, do you match that? No? Maybe I typed in my equation wrong. Somebody got that?
Yeah.
Okay.
So I want the point right at the very top.
Yep, so you second calc. Did you second calc?
Yeah.
Wait, no, you have to set your left bound, move the cursor over here and press enter. This is stuff we did a long time ago even.
I know, I didn't have my calculator.
Well, all right, now, number 6, question number 6 says, find the maximum volume of the box. So your answer is either 3.62 or 774.16. Which one am I going to pick for the maximum volume of the box? 774. So 774.16 cubic inches is the maximum volume of the box. Y gives you the volume. X gives you the size of the squares. So if you were going to build the box and you wanted to know how big the squares needed to be, then the answer would be 3.62. But our question said, what's the actual volume? So that would be 774. All right, good job. Number F, letter F. We already talked about problems like F. You should be able to whip this one out. Find the cost of a sweater that originally cost $52.50. So we start with $52.50. It's on sale for 25% off. So we're losing 25%, which means we're going to multiply by what?
0.7.
Yes, someone was paying attention. We never use the actual percentage. We either add it to 1 or subtract it from 1. This one's getting subtracted because it's a discount. Then we're going to add on a 7% tax. So what am I going to multiply when I add on? 1.07. This is 1 minus 25%. This is 1 plus 7%. So then we just type it in. So 52.5 times 0.75 times 1.07. Round it off to the nearest cent. And I got $42.13. Did you?
Let's get it. Let's go.
Find the final cost of your restaurant meal. Here we go. Same thing. Find the final cost. The food costs $23.12. There's a 7% tax, and you leave a tip of 15%. Right now, this is a little different because aren't they both add-ons? You're adding on 0.7 and you're adding on 15%. So what are we going to multiply by? 1.07 and 1.15. They're add-ons.
Would you be able to multiply it by 1.2?
No. It doesn't work, unfortunately, because if you multiply it by 1.22, you'd be taking 22% of this. I mean, you'd be adding on 22% of this. When you do it separately, you are, so let's say I did the tax first, all right, so I get a number. And then I'm taking 15% of that new amount, not just the original cost of the dinner. You see what I'm saying? It's purely built on itself. So no, you can't do that. They have to go separately. All right. We're going to get one more done, and then we'll be calling it quits for the day. All right. H is what we call a mixture problem. I promise you on your test, there will be a box problem. There will be a problem where you have to find the cost of something with tax and all that, like these. And there will be a mixture problem. You did these in first year algebra. In a mixture problem, you have two things that you are going to add together. So let's say I have a big bucket here, and I dump in some lemonade that's weak lemonade, and I dump in some really strong lemonade, and then I would have a mixture that's kind of medium lemonade. Would you agree with me? So what's happening in this problem is we have 12% lemonade mixing with 20% lemonade, and we're going to end up with 18% lemonade. Now, there are lots of different strategies, and I'm not sure how your first year algebra teacher did it. But what works for me is a simple little statement: amount times percent plus amount times percent equals amount times percent. In other words, amount times percent of the first kind of lemonade plus amount times percent of the second kind of lemonade is going to add up to be the amount times the percent of the final lemonade. Now, the good thing about this is there are 6 numbers in the problem. And 4 of them, you already know right off the bat. If you can read, you can fill in 4 of those blanks. What are the percentages? 12. So 0.12 goes right here. That's the percentage. What's this percentage? It's the other one I'm mixing. So what would it be? 0.20. And what's the final percentage? 0.1x or 0.18? Can everybody see where those numbers came from? Now, you know one more number in the problem. You know 18 gallons. Where am I going to put the 18 gallons? Which parentheses? The middle one. Because the problem clearly says you have 18 gallons at 20%. Now, the question says, how much of the 12%? So what if I called that X? Does that make sense to you? Then the quandary becomes, well, what goes down here? Use your common sense. Here's my bucket of lemonade. I dump in X and I dump in 18. So what do I have? Not 18 times X, 18 plus X. So I have 18 plus X gallons. Think about it. If you dumped in 5 and you dumped in 7, wouldn't you have 12? So if you dump in X and you dump in 18, you have 18 plus X.
Cathedrals, we come to the end of our day.
We might have All right, good class, folks. We got through a lot.